Now, very important thing, how to identify your sampling network. I told you the sampling network will take a portion of the output and give it as input to the feedback network. And sampling network, I also told you that we have two types of sampling: voltage sampling and current sampling, I sampling and V sampling, or you call it as voltage sampling or current sampling. So when the two types of sampling network is shown here, so you have an amplifier and you have a load RL. If you take the signal across the load, that is voltage sampling, because voltage is parallel, voltage is same across parallelly connected networks. So when you take the signal across RL, that is going to be voltage sampling. You can see the difference. So the connection is given across RL. So here from RL positive, I'm going to connect it to feedback network, and the lower end of RL, I'm going to connect it to feedback network, the upper part. So if I'm going to take across RL, that is going to be voltage sampling. If I'm going to take in series with RL, it is going to be current sampling. Why this is called as voltage sampling? Because voltage is same in parallel. Why this is called as current sampling? Because whatever current flowing through RL will flow through my circuit, because current is same in series. Based on these two logic only, they have defined voltage sampling and current sampling network. Any doubts you have in identification? Whenever you have from the output, I'm going to take parallel to the resistance any value and giving it to feedback network, it is going to be called as voltage sampling, because in parallelly connected circuits, the voltage value is going to remain same. But in series sampling or in current sampling, you know that I'm going to take the output current in series with RL. I'm going to connect the other end of RL directly to my feedback network. This is called as current sampling because the current is going to be same in series connected passive components. So whatever current flowing through RL is going to flow through the feedback network. Whatever voltage is available across RL is going to be given as input to the feedback network. So that is the reason why it is called as voltage sampling and current sampling. So in the first circuit, you see the output voltage is sampled by connecting the feedback network in shunt across the output. Here you can say the feedback network and RL are in parallel. Because I'm taking output across RL, so those two are in parallel. So this type of connection is called as voltage sampling or node sampling. So it is called as voltage sampling or node sampling, because at this node I'm going to take my output voltage. So between these two nodes I'm going to take my voltage. So it is called as voltage sampling or node sampling. So the same thing you can define for the second type of connection. It is called as current sampling. The feedback network is connected in series with the output. So it is called as current sampling or loop sampling. So we have seen Kirchhoff's voltage law and current law, mesh analysis, nodal analysis. In nodal analysis, we find the node voltage, right? So same way, node sampling means it is voltage sampling. In loop, mesh analysis, you find the loop currents, right? So loop sampling is also called as current sampling. See, all the names are related and they have significance. You should understand why it is named as voltage sampling or node sampling. Or if I say voltage sampling, you should visualize how the signal is taken across the output of your amplifier. It is taken across RL in a parallel way. In parallel, voltage is same. So you call it as voltage or node sampling. In current sampling or loop sampling, it is taken in series with RL, because in series the current is going to be same. So in that way, you have to relate and understand these two types without any confusion. So in voltage sampling is also called as node sampling. Current sampling is also called as loop sampling. And the sampling network is present at the output side, at the output of your amplifier, because the sampling network will choose whether you should take voltage or current from the output and give it as input to your feedback network. Okay, so sampling network is present across the output of your amplifier. So three networks we are adding in a feedback amplifier. One is sampling network, one is feedback network,